Okay, good morning, everybody. Thank you for attending my talk today. I've never done anything quite like this, the whole virtual streaming thing for a conference, but I hope it works well. Want to thank the organizers. They have a tremendous amount of work on their shoulders, especially with all the last minute changes to the conference, due to worldwide health concerns and that nature. So this is going to be fun. So let's get started. So my name is Will Foster. I am a systems engineer at Red Hat. I work on the performance and scale engineering side of the house there. I do a lot of heavy R&D work, and I have mostly a sort of a DevOps role. I kind of do about 70% development, 30% systems administration. So the talk that I'm going to give today is on deploying complex stacks with Ansible. So on my team at Red Hat, we have a very small team, about 3 people actually, of our core DevOps team, and we have a tremendous amount of infrastructure for 3 people. Nearing 1,000 bare metal servers for some of our large R&D performance and scale testing, and we manage the whole gamut of everything: the systems, the network devices, the architecture. And very often we are tasked with deploying and managing application stacks for various uses. This talk is going to be around Elasticsearch Stack as an example, and I actually have a demo for you all. But what we're going to go through is some of the lessons I've learned, some of the mistakes I've made, and I've made quite a few of them, and some really cool things that I've picked up along the way for kind of a best practice guide of how to write Ansible playbooks for deploying complex stacks. Now, when I say complex stacks, I mean Elasticsearch is a great example because it's got a bunch of components, but there's many other application stacks like it. And specifically, when you go to orchestrate these sort of workloads and these application stacks, you might have things like dependency services that rely on other services to be up before they can be instantiated, and all sorts of intermingling of service and application level dependencies. So let's jump right in. I'm sure everyone's heard of Ansible. Most people probably use it. If you don't use Ansible, you probably use one of the other fantastic config management systems like Puppet or Chef or SaltStack or anything. But this is going to be about Ansible because that's what we use. So I'm going to just kind of go very briefly over Ansible. I know this might be material that people already know, but what is Ansible exactly? So Ansible is a clientless configuration management system. It's written entirely in Python. It uses SSH as a transport mechanism, and it's very simple. It uses sort of a push mechanism rather than a pull mechanism, like say compared to Puppet, which checks in and pulls its configs in. Ansible, you just federate out all your changes out to all your systems. Super easy, super simple to use, very powerful. So why should you use Ansible? I should probably title this as "Why should I use configuration management?" You could replace Ansible with anything here. Well, you want to save time and resources so you can do other stuff. You want to lower deployment time. And really the main reason is you want to reduce complexity and human error. So one of my favorite movies of all time is Office Space. It's kind of a dystopian comedy. It's almost a cult classic, and it really epitomizes the worst place in the world you could ever work. So I have this little image here of, looks like you've been missing a lot of work lately. I wouldn't say I've been missing it, Bob. That's sort of how I feel about configuration management and using Ansible to automate things, because I don't miss doing any of that work. I don't miss doing any sort of routine or mundane or things that could be better left for automation. All right. So what are our goals for configuration management? And this could also relate to any other platform, but the number one goal is you want to strive for item potency. So you have your current state and your desired state. And Ansible, if it's written correctly, it shouldn't do anything if you run it multiple times. Once your systems or your set of automation tasks or your application stacks are deployed, you should be able to run your Ansible playbook over and over and over again, and nothing should change. Some other goals that we want to template as many things as possible. So we're going to touch a little bit on the Jinja 2 templating framework that helps us do that within Ansible. From a logical perspective, we want to break deployment pieces and objectives into kind of small logical parts that we can individually sort of divide and conquer. We want to make liberal use of configuration variables whenever possible. Everything, if we can, should be templated and variabilized, and makes things to be a lot more reusable. Lastly, we want to aim for more of an open-ended design. Typically, when you go along the task of, say, automating something, or say you're writing a playbook, Ansible playbook for deploying a certain application stack. In my experience, you're never done the first time you do it. There's always revisions you want to come back. There's always improvements. You get feature creep, or you might have other developers come up to you and say, hey, it's really cool you have this, but it would be neat if it also did this other thing. So when you're writing your playbook, you want to try to keep it as open-ended as possible so that it can be easily extensible, and you can also reuse some of that code. And then really the last thing is you want to use the Ansible provided modules wherever possible. There are a lot of these Ansible built-ins. The Ansible doc command can tell you a lot and list them all. The documentation on the internet is pretty good, but chances are if you're trying to do something and it's not too crazy, someone else has probably already done it. And probably that functionality exists within a module of Ansible. But of course you can write your own. All right, so I want to talk about how Baby Yoda writes Ansible, because we're just mere humans, and we can automate stuff and we can write code, but it's always a work in progress. But when Baby Yoda uses the Force, everything that it does is perfect. And the 3 pillars that Baby Yoda goes by when he writes Ansible playbooks is number one, he wants to compartmentalize all the roles. So that's really about creating sort of little manageable pockets of your playbook. You want to plan for growth and extensibility. More than likely, if it's a useful task, it's going to grow. It's going to have expansion. People are going to ask for more things to do. You're going to have to keep it updated. And lastly, you want to strive for item potency. So 3 of those pillars is what we already talked about, and that's how Baby Yoda sits down, and his 3 little fingers wriggle, and then just perfect code pops out. No bugs, nothing. We're not as lucky, so we have to try harder. All right, so let's get to some fun stuff here. This is going to be our complex stack example. We're going to deploy the Elasticsearch, Logstash, and Kibana stack, otherwise known as ELK. I'm going to have 2 VMs on my laptop, 2 CentOS 7 VMs, or if you're Italian, you might call it CentOS 7. So there's 4 components here. There's an Elasticsearch, which is kind of a search engine and a time series data store. There is Logstash, which is a very powerful sort of data collection and log parsing engine. There's going to be a Kibana component, which is going to do kind of our dashboarding and show us analytics, and we'll be able to actually visualize the data as it comes in. And then I've tossed a reverse proxy in front of all this, and I like Nginx, so I'm going to use that. And if you want to look at the code while we're doing this, if you want to do this yourself, it's right here on GitHub. Just github.com/sadsve/ansible-elk. And this is the playbook that we're going to be cloning and running on our VMs. And let's hope everything goes well. So diving into what these 2 VMs are doing specifically, let's start from the bottom and go up. I probably should have put host to 1 at the top there. So we have host-01, which is sort of our ELK Stack server. So all of the stack components from a server perspective are going to live on this VM. The Kibana, Logstash, Elasticsearch, Nginx, that's going to be there. And we have host02 is kind of a generic client. So you could have one to many clients, the way that this is written and the way that we're going to deploy it. But I'm just pick one because I have a tiny little laptop here that isn't that powerful. But host02, which is the client, is going to send all of its logs via FileBeat, which is sort of it's written in Golang. It's a super fast little log shipper. And it's going to copy logs it's going to send logs to Logstash, which is listening on host01. So I hope everyone can see. I hope my font's not too small. So I have 2 VMs running here, and I am going to actually tear these down. I have a little script that I use to basically revert my VMs from a QCal snapshot called vmreset.sh, and it's on my GitHub if you ever want to borrow this. So it's going to go through, and these VMs are already running. They already have data on them. I've already sort of tested this stack about an hour ago. So this is just going through and wiping all the VMs. So we're starting fresh. These are just bare bones CentOS VMs. There's nothing special about them. And I'm just doing a couple things here. I'm copying in my SSH key, and I'm recreating the network. So in a second here, these VMs are going to come up. They're going to be accessible, and we're going to start deploying Elasticsearch. And then when that happens, or while that's happening, we're going to walk through the kind of the meat and potatoes of this presentation of what kind of things have I learned over the past couple of years using Ansible, or what are the problems I've run into? What are the things that I could tell you that might help you to save some time? All right, so let's see, make sure our VMs are running. Yeah, cool. Yeah, so they're reachable. Cool. All right, great. So I'm going to pop over here to a terminal on my laptop. Now I am in the Git checkout of this repository that we just looked at here, github.com/sadspace/ansible-elk. All I've done is clone this repo, so it's fresh. There's been no changes. So the first thing that I want to do is I want to just take a look at the configuration options, and we keep that. There's a couple places you can keep this. I kind of prefer to keep it in group vars all.yaml, but there's a sort of a hierarchy of what supersedes another location if you have multiple files that have variables. But we'll jump into that later. So I'm going to take a look at this configuration file. Now in here, when I'm talking about templating things and variabilizing things, I really want to make use of the key value pairs in the YAML configuration, so that this Ansible playbook is flexible. There's a plethora of options here, like listening ports. Do we want to enable Elasticsearch XPack? Do we want to change any of the passwords? All this good stuff. Do we want to change the default user? Do we want to manage our firewall? Yes or no? You don't need to touch anything unless you want to. But this is kind of where the options are. So I'm not going to touch this. I'm just showing you where the file is. I think it's all going to be fine. The important thing to note here, I think, for this demo is our Kibana user and password is admin. So not the most secure thing in the world, but I think it's sufficient for a demo on my laptop. So we've looked at the configuration variables. We know they're there. We don't necessarily need to touch them. Here's one thing we do have to touch. We have to modify what's called the inventory file. So the inventory file just feeds Ansible a list of remote hosts that are classified by the Ansible group that they're in. So in this case, we already have our VMs here populated. We have one group here called ELK, and that is where our server is going to be. You generally only want one host here. Later on, when I add multi-node functionality to this playbook, you'll probably have more options. And then we have client. So we could have any number of clients here. We could have a ton of hosts here if we wanted. All right, but we're going to leave this as it is because it's good. And let's run this thing. So we're going to do Ansible playbook -i host install elk.yaml. Now, while this is running, let's go back to the slide. So I might pop back and forth and kind of see what's happening here. But we're going to be going through and we're going to be sort of instantiating this complex stack in a specific order. There's going to be things that we're going to be doing in here that I'm going to talk about that's going to help you do things like check if a parent service is available before the child services can be spun up. So there's a lot of useful stuff that's been baked in this playbook. So while that's running, typically I do like a Mandalorian impression here, like now you've had your snack, you've played with the button, now it's time to put your jammies on. So while this is running, see, we're just installing packages now. This might take a while. Everyone knows this mandatory xkcd. I've just modified it slightly. So instead of compiling, we're ansibling. All right, so we are getting work done. Okay, so let's jump into some of the things that can help you write your own playbooks and help you manage more complex stacks. So the number one thing you first want to look at is Ansible facts. If you're new to Ansible, or if you haven't really used this, the biggest mistake I see beginners do is they don't take advantage of the built-ins in Ansible. Ansible facts will crawl your system and gather an enormous amount of information about your hosts. So you can Ansible setup-m is the command to run the facts. But I'm going to use a practical example here for facts. There is a fact value called Ansible memory MB .real.total. So .real.total are just attributes of Ansible memory MB. This is the amount of memory that is on whatever host that you run the facts on, which you can then leverage to run conditional automation or conditional changes. This example here is going to automatically tune our Elasticsearch JVM heap size based on the physical memory that's detected on. So here we're basically going to say that anything, however much memory you have, we're going to give half of that to Elasticsearch up to 31 gigs of memory. Anything beyond 31 gigs is not really going to help you due to the way that Lucene indexes work and other things. So this will, you don't need to worry about, say you're deploying an ELK stack on a bunch of test VMs, but then you want to actually for real put it on a server. And your server's going to have, I hope at least 64 gigs of memory. You don't need to tune your playbook for every single host. This will adapt to the physical hardware or the virtual hardware in this case of whatever your destination systems are. So this is an example of sort of using Ansible facts to do this for you. All right, let's check in and see how we're doing. Okay, we have moved into the Kibana realm now. We've already set up Nginx, I think, and we're now installing packages. Kind of boring, nothing cool happening there. Let's move on to service dependencies with Ansible. So when you have very often there's interdependencies between services and stack components and other things. And before you can bring up one application or one service, it might be dependent on another service. And it might be dependent on multiple other services. There's some very powerful things you can use in Ansible. The URI module is probably one of my favorite, most frequently used modules in Ansible because you can have it check the status code of certain things. You can have it check the web content for a certain string or page, say, to say if a site is up. In this case, we are going to be using this to determine before we bring up the other parts of the stack that Elasticsearch is indeed up and listening and there's an index available. So if you were to curl this, localhost port 9200 _cat /indices indices, it's actually up and running, you'll get a 200 return code back. If you don't, then Elasticsearch isn't available and nothing else you're going to do is going to work because it all depends on Elasticsearch. So this specific task here in Ansible is just going to sit and retry and retry and retry based on the delay and the number of retries to make sure that Elasticsearch is up before it continues. We're also using the until, and this is sort of mandatory here in that you're telling it that you want the result of this register value ES service result to equal 200. And until this happens, your playbook will wait, and it will try for a sane amount of retries. Okay, cool. Look at this. We're actually doing this right now. Look at that luck. So under here, task in Kibana, it is before Kibana can work, it needs to have Elasticsearch. So here we see that it has waited for the Elasticsearch index content to return a 200, and eventually it does, which means our Elasticsearch portion of our stack is up and running. The current task that's running right now is now checking port 5000 for Logstash to make sure that Logstash is up. Okay, cool. Moving on. Here's another example. And actually, this was the one that we're waiting on right now, is checking for the Logstash port to be available. You can see here that I've variabilized Logstash syslog port. So if you did want to have it be configured to run or listen on another port, all you have to do is change that value in the first configuration file that we looked at when we started our talk. Awesome. Yeah, and again up here, wait for is really powerful for this. Until is another one that you're going to use. These are all kind of the bread and butter of dependency checking within Ansible to make sure that everything is orchestrated in the right order. Okay, so this is a screenshot of what we just looked at. Cool. One more example of dependency checking. This is yanked from another playbook. We've got a ridiculous amount of servers for a very small amount of people, like we stated. Some of these are Dells. And this is ripped from an old Ansible playbook that we use to call the Racadm command to do boot order changes within the BIOS of Dell systems. We've since now have written a tool to do that for us that uses the Redfish API, but this is from a couple years ago, but it's a good example of using the until functionality of Ansible in our task. So we're basically saying that until the boot results are like we like them, continue to try to get the results and don't go forward until that's done. All right, let's see where we are with the stack. All right, we're done. We're done with the server part. So I'm going to pause here for a second, and let's see how our demo turned out. Now, we've only instantiated the stack on host 01. We still have to set up sending logs to it on host 02, but there should be some local system logs there. So another thing that I do with my playbooks is I like to print instructions at the very end. So when someone runs the playbook, they have sort of very clear-cut instructions of what to do. So we're going to go to host-01, and looks like we got Kibana interface up here. Apologize if it's slow. I don't have the most powerful laptop in the world. Okay, we don't want to send people data. All right, so we have a Kibana interface up. And what we need to do now is create an index pattern. So you wouldn't normally know this, but it's printed in the instructions here. We're going to navigate to Discover. We're going to go to Kibana. We're going to go to Index Patterns. That's where we are. Now, I didn't automate this part because choosing how you want to do your index is more of a personal decision. There's several ways to do it. You can do based on timestamp. You can do based on, there's a couple options. Also, I didn't want to choose a name for somebody for the index. So I left this part of the playbook up for people to put in their own inputs. But we're going to do logstash -star. And we see that we've already collected some data here. So this data here is from the local syslog of host 01, which is running our stack. All right, so we're going to go to next step. And then this is really kind of there's no right answer here. This depends on your needs. I don't want to go too in the weeds with Elasticsearch, but I prefer @timestamp for the filter. But a lot of people have good reasons to use received at. You also don't even have to use a time filter. We're going to pick timestamp, and we're going to create our index pattern. Okay, cool. We got that. We're going to go back to Discover. And what we should see here are local logs that have been populated. There we go. From host 01, which is where our stack is running. So this is just stuff that's kind of pulled out of, varlog messages and syslog and other logs. We're sending everything right now locally. The next step is we're actually going to run the client playbook against the client, and we're going to send all its logs here too. All right. So we can see that that is in our instructions. So if you want to add clients and you want them to start shipping their logs immediately, we run this command here. So this elk underscore server is just populated by Ansible and by an Ansible built-in that looks up the IP address of anything that's in that group. And this is kind of the elk, this is the elk client group. So if we wanted to know what that was, it's here. All right, that's our inventory. So we're going to go ahead and run this, and this is going to set up the FileBeat client on host 02, and it's going to start shipping all of its logs to our nice, pretty Kibana dashboard here. So we're going to run this, and this will be really quick. There's not a lot happening here. It's going to install some packages. It's going to pull in the SSL certificate, and it's going and the key, because we want all our traffic encrypted. And it's going to do a couple other things, install FileBeat, and then it's going to set up the FileBeat service and ship all of our logs to host 01. At least that's what we hope is going to happen. If it does completely burn down in a fiery ball of explosion, then that'll be fun too. All right. And we're also we're installing a couple of other extra things that are useful, some FileBeat templates and other things. Okay, we'll come back to this. I don't think it'll take much longer, but I want to get back to some of our content here. So I also now I want to talk about conditional logic and using variables for conditional logic. You're going to probably do this a lot with more advanced Ansible stuff. And really the keystone functionality here is going to be the when clause. When is going to be your sort of conditional magic stick. You can feed in any sort of and or conditional logic and pass that to when, and it will be able to do things for you. So one of the things I like to do often is, in this playbook here, this is just a snippet of the roles that we're using. I'll show you the full list later. But this playbook supports both FluentD as your log parsing mechanism, or Logstash. I prefer Logstash, but some people like FluentD too. So this playbook will do both, but you can only have one or the other. So the way that we're able to not duplicate a whole lot of code is simply by just using this when conditional. And if whatever you set logging underscore back into is going to determine what that is. So you can sort of have duality in a playbook and have it take two completely different turns, but not really duplicate a lot of code. It will basically just omit running the code that you don't want to run by setting these conditionals. But there's no end to what you can do with sort of the conditional logic here. So, all right, let's go back to, let's see what's happening here. Okay, cool, it's done. Let's see if it's shipping logs. All right, so we're going to refresh here. Now we should start seeing stuff from host 02. There we go. Host 02, cool. So now we have both logs from the local host itself that's running the Elasticsearch stack, populating its own logs, over the local socket. And we also have host 02, which is a remote host that's sending all of its logs directly over to the Elasticsearch instance. And this could be any number of systems that you're just populating stuff. Our primary uses internally for Elasticsearch are usually around capturing performance and scale metrics. But we also ship all of our system logs, our network logs, all that stuff over to Elasticsearch as well, because it's nice to have one centralized place to search for things. And the dashboarding is pretty powerful as well. That's a whole nother talk. But cool. So it looks like we were successful and our playbook is working as expected. All right, let's talk about how you organize this playbook. There's no right or wrong way to do this. I'm just going to share with you what works for me. So the common sort of directory structure that you would want to have, or that I like to have for a playbook, is at the very top level is you're going to have an install directory. And all of your kind of core playbooks are going to be located here. Underneath install, you're going to have group vars, and this is where you keep your vars files or your variables files. And this can be one or many individual YAML files that have key value pairs of configuration values that you would like your playbook to know about and honor and absorb and use with your automation. This is also where ours is located. So we use install group vars all.yaml, for example. Underneath install, again, kind of going forward, we have roles. And roles are where you keep your sort of individual stack component roles. And then underneath your individual roles, so my role might be Elasticsearch, for example. You're going to have files if you want to keep static files. You say you have some binary blobs, or you have some archives or some kind of data that's fairly static. You would want to go in files. You then have tasks, and tasks is where your actual role tasks live in a separate YAML file that instructs from top to bottom what you want Ansible to run for you. And then lastly, you have templates. Now you could also shove handlers in here as well, but we'll get to that later. But templates are using what's called Jinja 2, which is a kind of a templating language that lets you template out configuration files and then populate those variables with things that might, I don't know, be kept in your variables files. The files and templates are optional. Only tasks is really sort of required if you use this format. But again, this directory structure makes it easy for me to keep track of very large playbooks. And I think it helps other people when they go to modify or add things to my playbooks, that there's sort of a consistent hierarchy of where things are kept. Okay, this is the full elk.yaml. This is the ELK playbook that we just ran that deploys the server side. So we can see underneath here, there is the playbook for ELK. The host is going to correspond to are ones underneath the ELK group in our inventory. And then there's a whole boatload of roles. Okay, so when we talk about the compartmentalizing of roles, or sort of making things as modular as possible, this is the practical example of that. And again, this is going to start at the top and go down, kind of this order. So at the very top, you obviously want to have your core parent service that one or many services might depend on. That's the first thing that you want to do. And then I've sort of ordered these underneath the instantiation order that I want them to be brought up as. Nothing's going to work in this case. Nothing's going to work without Elasticsearch. That has to absolutely come up first. Nothing will work without that. That's the core of what we're deploying. But everything else are going to be, ancillary, sometimes ancillary services, but they're going to be dependent services on this primary service. So, we have either Fluentd or Logstash as the second service that we bring up, depending on which one we want to pick to use. And then we have our friend, the win conditional here. We want to bring up our reverse proxy next. And we have our choices again between Nginx and Apache. I did port in Apache support here. Someone requested it. And then we have a couple other ones here. And really kind of the last thing that we bring up is Kibana, which is our dashboard, our very, very good looking dashboard here. It looks really sweet. Yeah, we got 20,900. Man, we're just pumping logs to this thing. Okay, cool. And then lastly, there's kind of some, after that are things that are not necessarily part of the stack, but they help. So we deployed firewall rules to open up all the ports that we wanted. And then, if you saw with this nice green text, we have our instructions. I'll go up a little bit more. Yeah, in the green. And I just use debug messages for these. They stick out quite well. They're easy to see. And then that's the last thing is instructions. But yeah, what you want to glean from this is you don't want to shove everything in one role, but you also don't want to go overboard either. I tend to do one role per major component. And if that major component has subcomponents, I will make a choice whether or not to keep that in the same role or break that out into individual roles. But it's purely up to you and what your needs are. All right, moving on. This should be obvious. You want to keep your playbooks in an SCM of some type. I prefer Git. I really like the branching functionality of Git, among other things. Specifically, that if you were to look at my Elasticsearch playbooks, I keep a branch per major version of Elasticsearch, dating back to the 2.4 series. So what we deployed today is a 6.8 series. So I keep a couple of branches that basically, if you wanted an older version of Elasticsearch, all you got to do is check out that branch. I maintain most of this in my free time, so I'm not going to backport support for a really old version if something breaks, but you get the idea, right? That branches are useful for isolating perhaps different versions or maybe different functionality, other things like that. All right, automate client operations when possible. So this is the ELK client. So this was the second part of the playbook that we ran that set up that client side. This made host 02 start shipping its logs over. This one's a lot simpler than the main stack. It's really just file beat. And then we've added a couple extra things that people have asked for on GitHub. So we got metric beat, packet beat, heartbeat. These are sort of ancillary Elastic services and functionality that you get. Metric beat's really cool for pulling in kind of system metrics. Packet beat tells you what's happening over the wire from a network perspective. Heartbeat is sort of HA kind of health related. So I'm not going to go into that, but you can read about it on the website if you want it. If you use my playbook, you're more than welcome to. I invite everybody to. It's open source. It's out there. You can steal it, whatever. You probably want to, if you're doing this for the first time, I would check out, I really, really like metric beat. But anyway, we'll move on here. All right, let's talk a little bit about CI, CD, and sort of testing and making sure the code that we write actually works and that there's no issues with it. So there's a very, very easy way to set up very basic testing for Ansible is Ansible comes with, or you can install rather, the Ansible lint package on most Linux distributions. I don't know about Windows because I don't use Windows, but it's probably there. I don't know. So yeah, Ansible lint is just like any other linter. It will go through, it will check syntax. It will check things that are syntactically wrong, missing pieces, artifacts in your file, anything that will keep your playbook from running correctly. Ansible also has its own built-in check mechanism, but it's as simple as this: Ansible-lint, point it to wherever your YAML files are located. Point it to your playbooks, point it to your roles, point it to your vars file, point it to anything that's a YAML file, and it'll go through and tell you if something's wrong with it. That's usually the first thing that I do when I'm writing something new is I'll locally just run Ansible lint on it. Then when I put it somewhere in a Git repo, I will set up CI to do this for me. At its simplest incantation here, if you were using GitHub, you can use other things too, but GitHub has really good integration with Travis CI. So I'm just using Travis as an example. But this is a sort of bare bones Travis.yaml, and this will tell Travis CI to basically run what I just told you to run manually. It'll pip install Ansible lint for you. You just include it into test requirements, and then you just tell it what you want it to do. And then Travis will go, and every push, every commit that you do to your playbooks, if it's stored in Git, will run these tests, and it will either pass or fail that change. So I have a in-depth guide here on my blog at hobo.house. that you can go, and I think I haven't written anything in a couple months, but it's the last article, and it'll walk you through setting up Travis CI for yourself on GitHub. You could also use it on GitLab, but GitLab has its own runners, so you may not even want to. But anyway, if you're interested in setting up very quickly CI for Ansible using GitHub and Travis CI, there's a guide there at hobo.house. All right, moving on here. So troubleshooting and debugging. So let's say something went horribly wrong and Ansible lint didn't find it. And how do we make sure that we have more verbosity for what we're doing, and we have a little bit better error checking as we develop Ansible? Well, I really, really like to use debug messages when I'm sort of modeling something. Um, we talked about Ansible facts that you can run Ansible setup -m against a host. It'll return a crapload of basically a Python dictionary of all of the hardware information and software configuration and other things that Ansible knows about your system. It just requires SSH and Python, so you may not be able to run Ansible facts against, say, a switch, because it probably doesn't have Python installed. But you can do other things to get that info. But the Ansible facts are really more for systems that A, have SSH installed, B, have Python installed. And you can do this on Windows as well. But this is how I sort of model things when I'm writing Playbook. I like to put in little stubs of debug messages to figure out what the return value would be, or what Ansible thinks it might be for, say, disks. So my root disk would be Ansible mounts and then index 0 of device. Okay. Same thing for my IP address. Ansible default IPv4 dot address will return what Ansible tells me my IP address is for the system. And this is incredibly useful for variabilizing and templating as much as possible for your playbooks. Sometimes I'll forget the debug messages and push commits with them in there. All right, here's another example, checking the operating system. And then here's our friend, the win clause. We are saying that we only want to see this message. Okay, we want to fail. We want to check what operating system we're running, and we're going to fail when Ansible operating system family is not Red Hat, or the Ansible distribution major version is less than 7. So, if you want to do automation against a bunch of different operating systems, different versions of those operating systems, and they might be intrinsically different from one another. They might be on a different platform, different Linux distribution, different OS entirely. Maybe you got some FreeBSD in there, a couple Windows machines with WSL, and then you got a bunch of Red Hat systems and some Fedora systems. Ubuntu's in the mix. You can use this win conditional, just this example here, to conditionally do things different respective to how those operating systems are different from one another. But when it comes to things like installing packages and other things like that, the beauty of a configuration management system is it should abstract that complexity from you. But oftentimes you will see intrinsic differences among different platforms that you can kind of use conditionals to work around and do one thing different on FreeBSD, but do something different on, say, Linux. All right, back to my playbook here. I've got some things in the pipe. We're currently on 6.8 for the Elasticsearch that we just set up, this beautiful, beautiful dashboard. I'm going to shut this VM down now because my fan's going crazy and I got a message on Zoom that it's affecting my CPU. So let's just kill that. All right, so we're on ELK Stack 6.8, and I'll typically wait a little while before I do the support for a new version of ELK. All the components have a new version. In my experience, every single time from one version, a major version, to the next, something breaks, something changes with the architecture or the software that's deployed with Elasticsearch, and the playbook needs some modifications. So it does take some time for me to kind of do it. But yep, I'm going to upgrade the ELK Stack to the latest version soon here. And then the major thing that I'm going to change here is, or I'm going to add as an enhancement, is I want to support multi-node deployments, because this playbook right now deploys the entire Elasticsearch on one host, which is okay. You don't take advantage of any of the sharding or any of the sort of innate redundancy that you have from multiple ELK servers where they all kind of share replicas. You lose all that when you only have one host. But at the same time, this is incredibly quick and fast to set up kind of an all-in-one, or in the case of our usages at Red Hat, we quickly spin up very temporal Elasticsearch stacks for engineers to send performance and scale results to. We capture those results, we spin everything down. So the multi-node's not quite as important for us, but it is something people have asked for, and I do think it would be useful to be able to just federate out the entire Elasticsearch stack against as many nodes as you want and have them all start talking, and the replicas shooting across and all that good stuff. All right, this is another way. This is a kind of an old Python snippet of using the ELK stack to record quads data. And I will tell you what quads is here in the next slide. But the Elasticsearch, this is basically a very, very generic, very ugly written Python 2 Elasticsearch input that pushes Elasticsearch data from one of our applications, actually from quads, which is what we use to deploy and manage all of our systems and networks. This pushes this to Elasticsearch. So I just wanted to kind of provide a God, if I should rewrite that. That was written like 4 years ago. All right. What is quads? I'm just very quickly, I want to mention this. So quads is a automation framework that's written in Python 3 that manages all of the 1,000 or so systems that we have and about 100 or 200 switches, and slices and dices large fleet of infrastructure based on a schedule. And it automatically provisions systems, sets up VLANs, sets up multi-tenant environments, reprovisions them, lays some stuff down on top of the operating system, and then hands those environments off automatically to engineers within the company, and they work on it for a certain amount of time, and then it gets reclaimed and it moves to somebody else. It's basically the way that we've automated our entire jobs with Python, which should be your goal too. Or Go or any other language, but you want to automate your job. And if you want to learn more about it, you can go to quads.dev. Like everything else that I do, it's all open source. So you can check it out there and look at the code. I want to mention as well, I'm about 9 months ago, I made a video course on Ansible. You can check this out. It's called Practical Ansible Solutions. And it's kind of a very quick video course of how to get up and running with Ansible very quickly. So that's something to check out as well if you're interested. All right. I have come to the end of this talk. I want to open up the floor for any questions. Before we do that, I'm just going to leave this slide up here for a second. This is how you can pull down my playbooks. I've got a couple Ansible playbooks up on my GitHub that might be useful to folks. I've got some articles, some blog posts, some guides on my blog, hobo.house, that you guys can check out. There's all manner of things there. And then you can find me on Twitter at Sadsfay, and I'm on IRC as well. I have been since the mid-90s as Sadsfay as well. And if you're curious about my nick, it actually doesn't mean anything. The first nick I ever had on IRC got taken by somebody, and I was so upset, I just randomly typed in a bunch of characters with one hand, and Sadsfay came out, and I was like, that looks cool. I'm just going to stick with that. That was like 1995 or something. So doesn't mean sad face. Just means nothing. All right. Let's see if there's any questions. Let's pop over to the little question site here. All right, cool. First question. Do you use some centralized platform for running playbooks like Ansible Tower, open source, AWX? Would you recommend such approach? I do not, uh, but I know a lot of people that do. Um, the cutoff for me, Ansible Tower, and it's open source. It kind of it's upstream. Well, Tower's open source as well, but AWX is sort of the. If you think about how Red Hat has commercial support, but CentOS, well, Red Hat Fedora is a better comparison. Fedora is sort of the what CentOS or Red Hat will become in the future. Um, I look at that's what Ansible, that's what the Ansible Tower is to AWX, with AWX being sort of the more bleeding edge upstream version of Ansible Tower. So we don't use Ansible Tower on my team because there's only 3 of us, and we tend to just have like the simplicity of having kind of one jump host that it serves as the goal of launching Ansible playbooks against stuff. This might be via cron, this might be ad hoc, but we just use one shared host, and it's kind of a jump host, and then that calls out to all of our, does all the Ansible heavy lifting. But Tower and its kind of upstream equivalent AWX is extremely useful when you have a larger team, or specifically if you really want to have kind of a segregation of access. Like, say you want to have a certain development group only be able to run playbooks against a subset of hosts, but you want to have another group only have access to something else. It's got really good separation of access. It's also got, if you kept your Ansible playbooks in multiple Git repositories, for example, it will sync to those. I do think it's worth checking out. And AWX can be spun up in Docker containers right away. There's I think there's an official one, but there's a couple floating around on Docker Hub and other places that on your laptop, if you just want to check it out, you can spin up the entire Ansible AWX stack in containers, and you can take a look for yourself. But if you had a larger organization, or if you just wanted a little more granular control over who can run what and when, or you wanted to kind of have that run and then gather metrics of failed runs, and maybe certain tasks in Ansible weren't as efficient as others, and it opens up perspectives into how can I make my playbooks better. There's really a lot of good analytics and kind of heuristic information you can get from Tower that you normally wouldn't have. So I would recommend everyone to at least check out um, uh, AWX, because it's free. I mean, you got nothing to lose, and if you got 45 seconds, you can spin it up in containers and try it yourself. I mean, what else are you going to do in 45 seconds, right? I hope that answers question. Okay, cool. Next question. What variable structure do you suggest? When to use group vars or host vars, and when to use role defaults or role vars? I think it's really going to depend on if you need to have a hierarchy of priority for your variables. Um, Typically, I like to keep things simple and put them all into group vars. But I know other people that put things into host level variables. I know that other people just like to have kind of at the top of the dependency chain, just to use the role defaults, because I believe that's kind of the top priority. So if you were managing multiple sets of variables, and in some cases you might want to leverage the natural order of, if you have it in role defaults, it's going to take precedence over, say, group vars. That can be useful. I tend to just go with group vars because I want to keep things all in one location, and I want people to use my playbooks, especially other developers. And I like to. It's just easier to have everything in one for what I do. I hope that answers the question. All right. Let's see here. How to use Ansible with Terraform. I do not use Terraform, so I don't know that I can give you a really good answer. I'm not going to waste your time and try here. When it comes to AWS, I use the AWS CLI, and I will use Ansible with that. And there's also some AWS modules inside of Ansible that are built for that sort of thing. I have some friends at other companies that their entire infrastructure runs on AWS. I'm sure a lot of you have stuff somewhere in Amazon, also Azure and other places. And Terraform is pretty powerful. It's pretty awesome. I just personally don't use it. All of my infrastructure, almost all of it, is internal and on bare metal. So we build our own cloud for R&D. All right, Terraform, Ansible, or both. Kind of refer back to my lack of experience with Terraform. I think you just got to pick whatever works for you. I don't see any reason to not mix them if there's a use. Let me give you an example. For a couple years, I worked on OpenStack as doing kind of DevOps operations work, but also a little bit of development. And one of our jobs working on OpenStack was to manage a public cloud on behalf of the OpenStack Foundation called TriStack. We ran this for a couple years. It's basically this gigantic bare metal cloud out on the internet that was open to the entire world, that anyone could spin up an OpenStack instance. It was pretty cool. And what the infrastructure folks in the OpenStack teams were doing is they would actually use they would use Ansible to ship Puppet manifests, and then they would have those Puppet manifests self-apply. So they would actually tie together two different configuration management systems and sort of leverage good aspects of both of them. So I think maybe there's something similar with Terraform and Ansible, that if one does something that you like better than the other, and there's no sort of intrinsic conflicts with resources, then by all means, go for it. All right. Any other questions? Okay. How are we doing on time here? All right, sweet. Well, listen, I really appreciate your time tuning in and watching me yap my mouth about Ansible automation and deploying complex stacks. If there's any questions that I couldn't get to, you can reach me on Twitter. You can also check me out at hobo.house. And I want to thank the DevOps Pro volunteers and staff as well for doing such an excellent job with a lot of tumultuous change in their conference format. So great job, folks, and thanks again for your time.